So guys, this is a classic AP problem as well. I imagine there's a good chance something like this might show up where you got to interpret things, interpret rates, integrals, net change, that kind of stuff. Although I think they took net change out of this exam because they took out that last chapter 8. But you still need to understand some of these basic things even for your future. So the rate at which rainwater flows into a drain pipe is modeled by the function r. So r is not how much water is in the drain pipe. It's the rate in which water is flowing into a drain pipe. And it's given by this function. Notice this is a calculator question, so I want you guys to use Desmos. Get used to that. And so it's cubic feet per hour. Make sure, because sometimes, hours, it might be talking about days. So our time is restricted between 0 and 8. That's how many hours we're going. It's from time 0 to 8. The pipe is partially blocked, allowing water to drain out the other end. So it's not completely drained. You can picture this thing being blocked. You got your pipe and rainwater's coming in, right, to this. And then it's partially blocked at the bottom, so it's not draining everything really fast. It's draining a little slower than water's coming in, probably. So it's going to be filling up. So there are 30 cubic feet of water in the pipe at time equals 0. So let's look at this, part A. So part A is asking how many cubic feet of rainwater flow into the pipe during the 8-hour interval. Now, it's not asking how much water is in the pipe after 8 hours. Then we have to include that initial condition, say 30 plus our change. This is asking how much flowed into the pipe. So what was the change? How much did it change by? How much did it increase by? So we're going to look at our rate. If we integrate our rate, that's going to tell us how much was that net change, how much came into the pipe in total. So we're going to go ahead and integrate from 0 to 8, because we want the first 8 hours, which starts at 0 and ends at 8, r of t. By the way, that right there, just by putting that is 1 point. So you need to show your work. It doesn't have to be crazy work. It just has to be some of the basic things. Now, this is a calculator problem. So notice in Desmos, it doesn't like t, but I put r of x and I typed in the function. Made sure I was in radians because this is trig. Make sure you're in radians. D of x for the other one, got that in here as well just to make sure if we need to use it. So how does Desmos work? Check this out. We press this square, and I'm going to go ahead and go to functions. Let me see. I found it earlier. Where's it at? There we go, functions. So right there, you'll find your integral function. So we're going from 0 to 8. And you don't have to type out the entire thing because I already said r of x earlier. So I'm going to put r of x. I need to get my parentheses. And now notice it's telling us a little error message here. We need to put dx. And boom, there's your integral, 76.57. And you don't need a reason on this one or anything. That's just simply the answer. That's 2 points, easy 2 points. Let's look at part B. So is the amount of water in the pipe increasing or decreasing at t equals 3 hours? So let's think about that. Is the amount of water in the pipe increasing or decreasing? How are we going to figure that out? Well, that sounds like a rate. We need to know, is the water in the pipe, well, the amount of water, if you think about it, the rate that it's increasing, what's the rate at 3 that it's coming in, minus the rate that it's going out, will tell us, the rate it's going out is d of t, remember? So d of t. So this is the rate of inflow. So we got the rate coming in and the rate going out. So if we take those two and subtract them, that's going to give us the rate at which, if it's going to be increasing or decreasing. We care about the sign here. Is it positive or is it negative? If it's positive, then the rate's going to be increasing because that means that the rate of it coming in is surpassing the rate going out. And if it's negative, then our rate is going to be decreasing because we want to know, is the amount of water in the pipe going up or going down? So how do we calculate that? We're going to go ahead and just use our Desmos. So let's clear that. And it's really easy. We'll have r of x, or r of 3 actually. Whoop. Minus d of 3. So that's going to equal negative 0.31. And I didn't emphasize that negative enough. So since there's more going out than coming in, that's why we get the negative number. Therefore, the amount of water, so since R of 3 is less than D of 3, the amount of water in the pipe is decreasing. Once again, how do we know this? It's because the rate of it coming in minus the rate going out, since it gave us a negative number, that means that R has to be less than D. So since R is less than D, that means that the water in the pipe must be decreasing at T equals 3 hours. And we'll go ahead and do part C and D